Okay, here we go. We're going to simplify some radicals. Yep, 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 yep. I feel like we got to talk really fast because these little chicks look like they'd be going yep, 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 yep. And here we go. If a squared equals b, then a is the square root of b. Okay, this thing right here is known as a radical. Most of you call it a square root. That's because when there's no number here, we assume that it's a square root. You're going to learn about other kind of roots next year in Algebra 2. But for right now, we're going to call it the radical. The thing underneath is called the radicand. So when we are simplifying, we're going to say, is there a number? So something times itself that equals 100. That's what we're thinking of. Well, hopefully you know that 10 times 10 is 100. So the square root of 100 is 10. And then they have this plus or minus sign in front of here. So when they're saying plus or minus the square root of 100, they're saying what number times itself gives you 100, and it's a positive. Well, that's going to be a positive 10. What number times itself gives you 100 and is a negative, and that's going to be a negative 10. So instead of writing both of them, we just put this plus or minus sign. On this one, they want a negative answer, so we're going to put a negative. Square root of 36, well, 36 is 6 times 6, so the square root is 6. 49 is 7 times 7, so the square root is 7. When you have a perfect square, such as 100, 36, or 49, when you say, what is the square root of 36, it is 6. People want to say it's the square root of 6. Nope, because if you multiply 6 times 6, you get the square root of 6 squared, and here's a little secret. The square and the square root cancel each other out, so that's how you get just 6. So if you look at square root of negative 121, it's different because it's got that negative sign in there. So if you try 11 times 11, you get 121. If you try negative 11 times negative 11, you get 121. You can't get negative 21 by multiplying the same number times itself. So what happens is there's a thing called complex numbers. Very complex. We'll simplify it for you. This is the symbol, just in case I write that, so you see it and you'll know what I mean. And what complex numbers are, this is the whole meat and potatoes of complex numbers. The square root of negative 1 is equal to this little letter I. Now, I do an I with the tail. You can do a cursive I. You can do a lollipop I. You cannot do that kind of an I because that looks like a 1. So make sure it's an I. Don't do a capital I because I'm sure that's reserved for something special. We're just going to do a lowercase I that looks like an I, okay? This is the best one because that's the way I do it. So you're going to take the 121 and you're going to hedge it. And the only prime number that goes into it is 11. You already know that because I just did it up there. But what's going on in your head is this is the square root of negative 1 times the square root of 121. So that means it's the square root of negative 1 times the square root of 121. We just learned right here, the square root of negative 1 is I, and the square root of 121 is 11. Now we don't write I11 because that looks goofy, so we're going to write 11I. So bottom line this, if you have a negative under a square root, you're going to bring out an I because the square root of negative 1 is I. That will come up in future slides. So let's go back to normalcy. 72, there's no negative, so we're just going to hedge 72. Remember our prime numbers, 2, 3, 5, 7, 11, 13 are the numbers we're going to use most of the time. So I see 2. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is a 9. 2 doesn't work anymore, so we're going to go with 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Remember, you got to get all the way down to 1. That says stop, which is not, I can't even come up with a rhyme. We're looking for perfect squares, so 2 times 2 is 4. The square root of 4 is 2. 3 times 3 is 9. The square root of 9 is 3. So we had 2 perfect squares in there. 2 times 3 were our perfect squares that made it out. And what did we have left? We had this 2, and you can include the 1, but I'm not going to. It's just 2. So the square root of 72 simplifies to 6 times the square root of 2. So So 52, it does not have a perfect square. So I'm going to take 52 and I'm going to divide it by the first prime number I think of, which is 2. And you can go to your calculator, you can do regular division, but you got to do the answer upside down. It's going to be 26. 2 will work again. It's going to be 13. 2 does not work. 3 does not go into 13. 5 does not go into 13. 7 does not go into 13. 11 does not go into 13. Oh, wait. 13 is one of our prime numbers. Remember, you got to get all the way down to 1. So now you're looking for perfect squares. 2 times 2 happens to be 4, which is a perfect square. The square root of 4 is 2. So I bring out the 2. What didn't make it out? Well, the things that didn't make it out also get multiplied, and that would be 13 times 1, which is 13. So this simplifies to 2 times the square root of 13. Now, if I squared that to see if I got 52, that would be 2 squared, which would be 4. 13 square root of 13 squared is 13, and that does equal 52. You don't have to do that. I'm just letting you know. Look at him. He's going, what? What? Do I have to do that? Do I have to do that? No. Okay, see this guy? We have stuff outside, and we have stuff inside. So here's what's happening. The square root is kind of like a jail cell, okay? You can't get out until you're perfect. So just like here, I had a pair of perfect 2's, so out came a 2. You have to be perfect to make it out. But outside is waiting for you. When you get out of jail, you got to have someone pick you up. So outside we have this 6. He's waiting outside, and then I'm going to put parentheses. What I'm going to do is set it up for simplifying. So this 6 does not get simplified because it's not inside the radical. I'm going to go down here and do that upside down division with 27. The first prime number that goes into 27 is 3. 27 divided by 3 is 9. I'm stuck with 3 until it stops working. 9 divided by 3 is 3. I'm stuck with 3 until it stops working, and I'm down to 1. Now remember how many have to be in a pair to be perfect? A pair of 3's. Remember, that's because 3 squared, the square and the square root cancel and brings me out a 3. Anything else have a perfect buddy there that I could square? Nope. So what comes out? 3. What stays inside the radical? What didn't make it out? 3 times 1, which is 3. Now what you have is a problem that says 6 times 3 times the square root of 3. Which ones can I actually multiply together? I can multiply the numbers that are outside. So what's 6 times 3? 18. And what's left inside? The square root of 3. So here's what happens. Let me tell you what you're going to do wrong if you're going to do something wrong. You're going to take the square root of 27, you're going to go down here, you're going to hedge it, and you're going to say the answer is 3 square roots of 3 because you're going to forget about that 6. So I want you to do this setup. I want you to have it set up with who's already outside and what's going to happen when I simplify inside. Okay, oh, look at, see, he's perfect. He cracked out of the egg. A little chick came out of the egg. Setup time, 3 square root of 16. Okay, so I'm going to go over here. I'm going to hedge 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. I'm looking for a pair. A pair of 2's comes out as a big 2. Pair of 2's comes out as a big 2. Everything outside gets multiplied. 2 times 2 is 4. What's left inside? 1. Well, here's the deal, guys. The square root of 1 is 1. That's because 1 times 1 is 1. Okay? Oh my gosh, I'm such a silly Willy. Was 16 a perfect square to start with? If it is a perfect square and you recognize it, you don't have to do that hedging. You can just say the square root is coming, or is simplified. The square root of 16 is just 4. So now everything's outside, there's nothing left inside, so my answer here is 12. Okay, so here we got to set up the 2, get ready for the square root of 25. Oh, 25 is one of those perfect squares. Here's what you might want to write down. Let's take a little pause. 1 squared is 1. 2 squared is 4. 3 squared is 9. Are you writing these down with me? 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Those you better have committed to memory. Then this makes your life easier if you know 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. If you know your first 15 perfect squares, that's really going to help you. You know where it helped you last time? It helped you in x squared minus 121. You would know to factor that to x plus 11, x minus 11. So know these perfect squares. Make sure those are written in your composition book. We want to see them. So is 25 a perfect square? It sure is. What is the square root of 25? 5. Remember, when you're answering what is the square root, you're saying what times itself gives me 25. Nothing's left inside, everybody's outside, so 2 times 5 is 10. I'm feeling a checkpoint. Are you feeling a checkpoint? Oh my gosh, I'm not psychic. I thought there would be a checkpoint. Okay, look at him. He's looking at me like, what you thinking about, woman? There is no checkpoint. He's going, checkpoint, checkpoint. What's a checkpoint? Checkpoint, checkpoint. Let's move on. Okay. Ooh, look, here's kind of a little radical right there in the little chick's feet. Simplifying square roots with variables. Okay, so numbers we can hedge. Variables we can also hedge, because let's look at the square root of x to the 4th. How many x's is that? That's 4. 1, 2, 3, 4. So there's a perfect square, brings out an x. There's a perfect pair, brings out an x. X times x is x squared. Let's look at the square root of x to the 10th. I'm going to write them sideways because I'm out of room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a pair of x's, brings out an x. A pair of x's 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 brings out an x. 1, 2, 3, 4, 5. That equals x to the 5th. What do you notice about the original power and when I take the square root? 4 becomes 2. 10 becomes 5. It's just divided by 2, isn't it? So if you have the square root to an even power, the answer is just that even power divided by 2. Now here's where the problem comes in. What if I take the square root of x to the 5th? That's 1, 2, 3, 4, 5. Pair of x's brings out an x. Pair of x's brings out an x. X times x is x squared. Uh-oh, I have an x left inside. He didn't have a partner. So I feel like I should do orange for these guys' feet, huh? Let's do the square root of x to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 1, 2, 3, 4. So there were 4 x's that made it out, 1 that did not. So if you have an x to an odd, for right now, you're going to rewrite it as x to the even, and it's going to be times x to the 1. So it's going to come out to x to the even divided by 2 times the square root of x. So let's look at that. This x to the 5th, I would have rewritten. I would have gone down to the next even number, which is 4 times x to the 1. 4 divided by 2 is 2, leaves one of those x's inside. Here, I would have rewritten this as the square root of x to the 8th. 9 is odd, take it down 1 to make it even, and x to the 1. Because remember how we do x to the 8th times x to the 1? That's 8 plus 1, which is 9. 8 divided by 2 is 4, leaves me with an x. All right? All right, so what we're looking at is the square root of a to the 4th and the square root of b to the 10th. These are even numbers, right? So I take 4 and divide it by 2. It is a squared. Remember, because a squared times a squared is a to the 4th, so you have a pair of a squares, brings out an a squared. This video. So then we've got b to the 10th, and it's the same thing. It's the power divided by 2. The reason there's a 2 is because it's a square root, because you need 2 of them to be a set, right? So basically that means we have 5 sets. So if I had b to the 10th, just for funsies, and I divide it by b, that would give me b to the 9th, right? Because b to the 10th over b to the 1st is b to the 9th. Divide by b again, that's b to the 8th. Divide by b again, that's b to the 7th. Divide by b again, that's b to the 6th. Divide by b again, that's b to the 5th. I got to write smaller. Divide by b again, b to the 4th. Divide by b again, b to the 3rd. Divide by b again, b to the 2nd. Divide by b again, b. Divide by b, I get 1. So if we go the same route and we look for pairs, there's a pair of b's, brings out a b. Pair of b's 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 brings out a b. So you have 1, 2, 3, 4, 5 b's. That's where that come from. You have 5 groups of 2. So your final answer here is just a to the 2nd, b to the 5th. Okay, on this, there's supposed to be a negative here. It did not show up. So the first thing you're doing is you're changing this to -1 times 25, x to the 6th, y to the 12th, z to the 2nd. Remember, this square root of -1 comes out as an I. So now the next thing you're looking at is the square root of 25. There is one, it's 5. The next thing is x to the 6th. So it's power over 2, because you want to see how many groups of 2 are in there. So that's x to the 3rd. Then you've got y to the 12th. So take 12. How many groups of 2 are in there? There are 6. Then you've got z to the 2nd. Divide by 2. How many groups of 2 are in there? It's z to the 1st. So you're going to put this all together. 5 comes first, then the I, then x cubed, y to the 6, z, and I'm too lazy to write the 1. So here we go. 2. Is there a square root of 2? Well, if I divide 2, I just get 2. It is not. So I'm going to leave it inside. This is odd, and this is odd. So I'm going to rewrite it as x to the 6x, y to the 8th, y. Always rewrite it with the evens. Now, what comes out? This one and this one are even, so I'm going to divide them by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Everybody else didn't make it out, so the 2, the x, and the y stay inside. All right, I'm going to take this 45 and I'm going to hedge it. I'm going to go over here and I'm going to hedge 45. It's getting pretty long. So that's divided by 5, which is 9. Divided by 3 is 3. Divided by 3 is 1. So I'm bringing out a 3 and I'm leaving in a 5. At this point, I'm going to make sure everybody is even. He is not. So I'm going to rewrite that as b to the 4th b and keep this as c to the 6th. So I keep the 3 and then I do the setup. A to the 4th is even. 4 divided by 2 is 2. B to the 4th is even. 4 divided by 2 is 2. C to the 6th is even. 6 divided by 2 is 3. Who is left inside? A 5 and a b. Now I got to just multiply. So I have 3a squared, b squared, c cubed times the square root of b to the 5th. Holy McMullenstein. Moving on. Rationalization. Oh my gosh. This is what you're all going to look like right here. This is going to be you when you are rationalizing. You're going to go, what? Here's the deal. You cannot leave a radical, are you writing this down? In the denominator. You cannot. So you are going to do what's called rationalization. A radical is called an irrational number. We want it to become a rational number, a number that makes sense. The square root of 3 doesn't make sense to us. So what you are going to do is you are going to multiply both the numerator and the denominator by the denominator again. Okay, we'll talk about what that actually means when we do a problem. So write that down. We might put an asterisk there because we might change it a little bit depending on what we have in the denominator. All righty, so we've got the square root of 12 or the square root of 5. First thing I want you to do is if they're both under square roots, both under square roots, I want you to ask yourself, can you simplify? If they're both under square roots, you can try to reduce it. For example, if you have the square root of 6 over the square root of 3, that's the same thing as the square root of 6 over 3, which would be the square root of 2. Here's the deal. You can't do that on any of this, but I wanted to talk about it. So this is what I said. You're going to multiply both the numerator and denominator by the denominator. The denominator is the square root of 5. Now remember, everything inside the radical can get multiplied. Everything outside the radical can get multiplied. So up on the top, inside, I have 12 times 5. On the bottom, I have the square root of 5 times 5. Okay? 5 times 5, remember, is 5 squared. So what does that come out as? It just comes out as 5. 12 times 5 is 60. So I'm going to go over here and I'm going to hedge 60. All right? For the sake of time, I'm doing a little zippy hedging because we're getting a little tired. This is a long video. The 2's come out. I have 2. 3 times 5 stays inside. So it's 2 times the square root of 15 over 5. Okay? What came first, the chicken or the egg? That's what we're trying to figure out. Right now, we're just trying to figure out, this is hard stuff. So we're going to do a few more. Got a radical in the denominator, so I have to do what's called rationalizing. I do that by multiplying by the square root of 3 over the square root of 3. For guys, or you're going to be, we got some stars, we got a visitor here, so if you hear some talking in the background, we're just going to say, hello, Brandon. Everybody say, hello, Brandon. Hello, Brandon. Okay, never mind. All right, so up on top, I'm going to multiply 8 times 3 because they're both under the radical, so that's the square root of 24. On the bottom, 3 times 3, I'm just going to leave it as 3 times 3 because we know that comes out to 3. You know what, guys? You can skip that step. If you have the square root of 3 times the square root of 3, it just equals 3. Let's hedge 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. Divided by 3 is 1. You bring out a pair of 2's. Inside 3 times 2 is 6. So your answer is 2 square roots of 6 over 3. Okay? Now, for those of you that are worried about me, I'm not talking about the pictures. Oh my God, except look at this one. That much because this is a really long video, but I love this picture. Isn't that cute? We love everybody. We love all our little chicks. I love it. I love it. I love it. So sometimes it's all under one big radical. Sometimes it's under 2 different radicals. This one, though, it's the same thing as the square root of 15 over the square root of 2. So in order to rationalize, I'm going to multiply by the square root of 2 over the square root of 2. Remember, we just talked about that. That just gives us a 2. Again, that's because it's 2 squared. Square and square root cancel. 15 times 2 is 30. So I'm going to go over here and I'm going to hedge 30. Remember, I'm doing zippy hedging now because I'm kind of tired of this. It's been a really long video. Oh, nothing happened. Nothing comes out of that. So it's just the square root of 30 over 2. I can't divide 30 by 2 because 30 is inside, 2 is outside. Now on this one, this is the same thing as 5 over 15. Does 5 over 15 reduce? It does, to 1 over 3. So if you see that and if you can reduce, you're going to be dealing with smaller numbers. So I'm going to do this 2 ways. I'm going to pretend I didn't see that. So I would have the square root of 5 over the square root of 15. In order to rationalize, I'm going to multiply by the square root of 15 over the square root of 15. We know on the bottom that gives us 15. On the top, that gives us the square root of 75. So I have to hedge that. 5 goes into 75. That's not a 2. Come on, Evans. 15 divided by 5 is 3. Divided by 3 is 1. I've got a pair of 5's. So I bring out a 5. I have a 3 left inside over 15. Now here, I'm glad I did it this way because here's a new thing. 5 and 15 are both outside of the radical. That means I have to go back to 3rd grade. Can I reduce 5 over 15? I can. 5 goes into 5 once, 5 goes into 15 3 times, but I have to leave that square root of 3 up there. Okay? Second method is if I did see that it's the square root of 1 over the square root of 3, I could rationalize by just multiplying by the square root of 3 over the square root of 3. Up on the top, that gives me the square root of 3. On the bottom, it gives me 3. Do you see how this is a bada bing, bada boomer, but we get the same answer? So if you see that you can simplify inside, do. If not, you're going to have to simplify at the end. 6 of one, half a dozen of the other. And by the way, I just love these. Are they just not absolutely adorable? This is my favorite. Okay. Oh, okay. He's kind of scary. I think what he's saying is do the checkpoint. All right. So Some of these, as I'm just glancing at them, they can simplify. Do that first. It's going to make your life easier. If not, remember you are rationalizing. Multiply both the numerator and denominator by the denominator. I believe this one wins longest video yet. See ya.